Does anyone know what a plus b squared means with multiplication? So this is a term squared, but what does it mean with multiplication? Anyone know? Yep. Hayes? It just means a plus b times a plus b. That's all it means. It means that this is used as a factor twice. So go ahead and multiply that out. Let's see what we get. And you can use your method of FOIL, or if you're like, I don't remember FOIL, distributive property. And what do you get when you multiply a plus b times a plus b? All right, when you multiply that all out, did you get, a squared plus 2ab plus b squared? How many of you got that? Okay, good. So multiplication, pretty good with your FOIL or distributive property. Okay, I'm going to give you one more up here. Go ahead.
When you did B time, or when you were doing FOIL and it was like AB plus BA.
Yes.
Is that A equals B squared or 2AB?
Good. It's going to be 2ab because you had 1ab plus 1ba or 1ab, so it gives you 2ab. Yes, and that's actually a good point. A times b is ab. B times a, you can write it as ba or ab, so that they're two like terms, and I get 2ab. All right, can you guys break that into multiplication? What would that be? A minus b squared means, Josh? It doesn't mean that. That's one of the most commonly put. Good. It just means a minus b times a minus b. And then you multiply that out, you get, and you can work it out. And as you work that out, do you guys remember that that's special? Anyone remember special? Do you guys remember 9-8? If you're done waiting, flip back to 9-8. I just want to know the title of that lesson, 9-8. What in the world is 9-8 about? That's like weeks ago, right?
Special products.
Whoa, yeah, and if you remember, maybe you don't, that's okay. This gives me a special product. Here it is. And this one gives me a special product that's right here. Does anyone know why they're special? Okay, I know two boys know. Yes, Lizzie? Very close. Something about the squaring. This is why they're special. Ready? When you're given a problem that looks like this, you can automatically get to the answer right here. And when you get a problem that looks just like this, you can automatically get the product. What do I mean? Let's go to the next one I'll give you, and we'll do this one together. V plus 3 squared. Okay, this is called the square of a sum. Okay, the square of a sum. I already know the answer, boom, like that. You know why? Because it's special. Does anyone know what the first term would be? V squared is the first term. Automatically, it's V squared. Does anyone know what the final term would be? Yep. Eli? 9. Positive 9. How did I get that? What's V times V? V squared. What's 3 times 3? 9. But the middle term is where people have trouble. Does anyone know how to find that middle term? It's special. Okay, Walker?
You just take 3 and V, and 3V times 2 is 6V.
Good. You do V times 3, which is 3V, and then multiply by 2. You get 6V. That's the product. Okay, so you should be able to, hopefully, soon, pick that out. Here's your product. Here's your problem. There's your product. Another one. Please be careful on this one. 3P minus 2Q squared. Okay, so you can get automatically to the product just from the problem. 3P minus 2Q squared. Okay, Taylor, what's the first term in my product? 9p squared. It's just 3p times 3p. Okay, Vivian, can you get me that last term? Positive 4q squared. Middle term. Oh, oops. This one's the hard one. How do I get this one? Wyatt, do you want to try?
Sure.
Thank you for your willingness.
Would you combine them or just do like 6p minus?
Okay, you're going to multiply 3p times 2q. What's that? 3p times 2q. 6pq, and then you double it. So what's that?
12p squared q squared.
So it would seem like that, but it's actually just 12pq. And it's negative 12pq. You know why it's negative? Because of that negative sign right there. That's your product. How many of you were able to go from the problem to the product fairly quickly? Maybe not instantly, but fairly quickly? Okay. We'll get more practice on those. Yes, sir. Questions?
So isn't this the same lesson as the special product?
No, this is the intro to the lesson.
Oh, special product is the intro to this?
Yep. So, can I ask you this? What's the title of this lesson, today's lesson?
Perfect Square.
And factoring. Did we factor yet? No, we've just been multiplying. But I hope that helps us to see there's a relationship between the problem and its product, and that same relationship exists backwards. That was too easy to be true. Okay, here it is. I'm going to give you a couple notes. Perfect square trinomials. What in the world did he just say there? Perfect square trinomials. Okay. Perfect square trinomials have to have how many terms? It has to have 3. Why? Because it's called a trinomial. And then perfect square. What in the world does that mean? If you wrote that down, I'm going to go back. This is a perfect square trinomial. Well, let me ask, how many terms does it have? 3. So that already qualifies it as a trinomial. But is it a perfect square? Yes. The reason is, can you square root the first term? Can you square root that? Okay, can you square root the third term? And then the last question, or the last part of it, is the middle term, and please listen carefully, is the middle term, right here, the product of the square root of the first times the square root of the second times negative 2. So ready? What's the square root of 9p squared? 3p. What's the square root of 4q squared? And then times negative 2, what does that give me? Okay, if its first term can be square rooted, third term can be square rooted, and you can say this about the middle term, this is a perfect square trinomial. Is this a perfect square trinomial?
Which one, the top one?
Top one.
Yes.
Yeah, it is. Is the first one able to be square rooted?
Yes.
Third one?
Yes.
Is the middle term the product of those square roots times 2? Yep. What's v squared square rooted? V. What's 9 square rooted? Times 2. So that's a perfect square trinomial. We're going to be doing this over and over on this lesson. And I'll write it down so you guys don't forget it, because it is kind of tough. Questions, though? I hear kind of a questioning vibe. I got a questioning feel here, like, huh? Is that really true? Yeah, go ahead, Hayes. Sorry? Good. The big difference, I think I just heard it. You see how this is a difference? So you're going to use negative 2. You see how this is a sum? You're going to use positive 2. So that's really that's it. Is one a difference? One's a difference. One's a sum. Negative 2 or positive 2. So yeah, good question. Because we're going to have to answer that as well. Perfect square trinomials can be factored into one of these two forms. The first one, a plus b squared, So it can be factored into that, or it could be factored into a minus b squared. So when we factor our problems for this lesson, you're either going to get it in this form or this form. Okay, it's going to be one of those two forms. So that's what we're looking with perfect squares and perfect square trinomials. Okay? All right. I think we're all good with this. This next note, I wrote it for your benefit, and so you can reference it when you're answering these questions. So I'm going to ask it in question form. Is this a perfect square trinomial? That's what we're going to ask a lot today. Is it a perfect square trinomial? What a great question. Let me answer that question with 3 questions. That's how you're gonna figure it out. First question, and we've already talked about this. Is the first term a perfect square? And we'll go through example after example of this, I hope. Is the first term a perfect square? That's a question mark at the end. Is the first term a perfect square? Does anyone remember what the second question was? Is the third term, and I'll put here the last term, is the last term, and then you can use this to help you with your notes, a perfect square. Is the last term a perfect square? That means, can it be square rooted? And you'll have to answer yes or no. The last question is the hardest one to write down because you have to consider everything. Is the middle term the product of the square roots of the first and last terms? I'll move this here. Times 2 or negative 2. Man, that's a lot. Question mark. So if you ask me, is this a perfect square trinomial? I have to ask how many questions? 3. Oh my. And by the way, guys, the questions are longer than the actual thought process. Like the thought process should be, oh yeah, or nope. It's very quick. Other than the third one, these should be very boom, boom, boom. And we'll look at it. And then the third one, we need to think about it a little bit longer so that we don't make a mistake. And I'll show you that in just a moment. I need a little break here. Yeah, Taylor? Thank you. The last slide? That's all right. You know what I do when I get home, guys? I get home, I say hi. I wish. I get home, I say hi to my family. And then I get a nice little tub of ice. Throw my arm in there. Just let it cool down. Then I take it out after an hour. Okay, maybe not that long. After a minute, I sit down at my table, smell the food cooking, sit down, do some problems. And then my son comes up, Ezra, not Titus, because he doesn't care. Ezra comes, sits on my lap, and watches me do math. Then I look at the sun setting, and I sigh. Job well done. Okay. I don't think that's how it goes. That'd be cool if it went like that. Ezra only once has come up to me when I'm doing math, and he's like, "What are you doing, Daddy?" And it was geometry, so it was more interesting for him than algebra. Come on. But that was fun.
So does Titus actually come up on your lap?
No, Ezra does. Titus will sometimes, but he just wants to drool on me, or hug me, or just tackle me. He's more physical than Ezra is.
Dude, Ezra or Titus like 4
They are not allowed to play that game. Just because I said so. Okay. Oh my. Oh man. Let's not start. Of course, I'm not going to start with that. I actually have. I do have. Well, when I was younger, I had like the old Nintendo and the old Super Nintendo and all those, and I'm going to let him play that first. Just go through the history of what it used to be. Like, you can play this and play that, and then it gets 3D, and he's going to be like, whoa. Okay, maybe not.
You can get more games for those consoles.
Yeah, they have. Okay. Let's move on, because I can get stuck on that. Here I have my my trinomial, and what's always my very, very first step on any problem, even up to today? Good. GCF. And I asked the last class this. How many of you came up to me while you're taking your quiz and I was working at my desk, and you came up to me and I said GCF, and then you went away. Anyone remember that? I remember you. And that is usually a good first step. You're looking at, man, I don't know what to factor. GCF. Oh, man. So what's the GCF here? It's 1, so you don't have to do that. But always check that because it could be a possibility. Okay, I'm going to ask 3 questions. What's the first question? Is the first term a perfect square, yes or no?
Yes.
Yes, I'll put a little y under it. That means yes, it is a perfect square. Second question. Give it to me and then we'll give the answer. Is the last term a perfect square? And what do you guys think? Yes, those 2 questions should be answered very, very quickly, hopefully, and very confidently. The third question is what? That's the wordy one.
The middle term of product and square roots of the first and last terms times 2 with negative 2.
Okay, here's how you practically do it. This is how you practically do it. You're trying to find out, is that middle term a yes or a no? What's the square root of 4y squared? 2y. What's the square root of 81z squared? 9z. And then you're going to multiply it by which one? 2 or negative 2? What do you think you should do it by? By positive 2. And then is this right here a multiply together to get me the middle term?
Yes.
So that's a yes. If you say yes, 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 you have to say yes to all 3. Then it's a perfect square trinomial. And now you're ready to factor it. Oh. You're ready to factor? Okay, ready, guys? Ready? I'm going to factor it here. You see how I get these numbers? It's going to come in this form. It's a perfect square trinomial. Ready?
Oh my.
Done. Where did I get those numbers? That's important to know. Where did I get them?
Perfect square trinomial.
Yeah.
Where you said yes or no and check.
Remember that third question? What's the square root of the first?
That is crazy.
What's the square root of the second? And then you just square it. And it's a plus sign, by the way, because that was a positive 2. That's it. That's all you do to factor it.
Why'd you put 2 on that one side and not on 9
Okay, this 2 right here, this is what I have to multiply the square roots of these by to get that. But this is not a part of the actual factoring. Well, I guess you could say it's right there, but yeah, that's kind of a nice little pattern. Okay, let's do another one, just to get some practice. B. Example 1b. So we have 9n squared plus 49 minus 21n. What's the very, very first question I asked?
Oh, wait.
GCF.
Yes. Wait.
Sorry, Mr. A.
No. Okay. How about this? If you come to me during the test and you're like, Mr. A, I don't know what to do, I'm going to look at you. And then I'll say, go away. And then that's our code for why weren't you finding the GCF. Okay.
But what if that's not the issue?
Then I'll say, good luck. No. Yeah, try your best. I hope it's not the GCF. Okay, but I'm looking at this right here and thinking, like I can already see it's a no, right? But there's something different about it. It's not written in descending order. Do you guys remember order? Order matters. This is not in order. Do you guys notice the n to the second? Shouldn't n to the first be here, then n to the 0? Okay, the order is not in descending order. Just rewrite it in descending order. That's when you could start it up. So with I think is this last chapter, yes. Writing it in order. Do you guys remember we had a quiz and a test on that? You got to write it in descending or ascending. That helps you out on this chapter and this lesson in particular. Okay, now we have no GCF. Now we can ask, is it a perfect square trinomial? What do you guys think as a class? First term, is it a yes or no?
Yes.
It is a perfect square because you can get 3n times 3n equals 9n squared. Good. Second question is the third term or the last term a perfect square? Yay. The last question is this. Is the middle term the product of the square root of 9n squared and the square root of the last term and plus or minus 2? Yeah, negative 2 here.
No.
Yeah, we put the end.
Okay.
Yanni.
Your answer on this? The answer on this is no. Good. Actually, so who said prime? Who dared to say prime?
Why?
Okay, why? The guy who's hiding there. Honestly, on these problems, you are going to get prime for some of them, but I need you guys, please put on your thinking caps. This has been a whole 3 days ago. If you have a trinomial that cannot be factored in today's lesson, perfect square trinomial, you can't do this. It's yes, yes, no. Is there any other way to factor it?
No. Yes.
Wait,
Unfortunately.
Yes, there is.
yes.
What is it, Taylor?
We multiply the first and the last.
Yeah, well, I'm not asking you to do this on most of these problems, but could you do these two multiply together? Then we can find out what two factors that have to be. Okay, can you do that?
Yes.
Okay, so this one's prime, by the way, so why you're good, it was prime, but you could have tried that one out and you would have figured that it was prime.
We're doing the perfect trinomial thing here.
You're welcome. How many of you are getting this? Okay, I'll give you some practice to see if you're doing it well or not. Page 591, number 10. Okay, a lot of people in the last class are like, wait, Mr. A, what do you want me to do here? Great question. Determine whether each trinomial is a perfect square trinomial. You say yes or no. If it is, factor it. What if it's not? Don't factor it. You just put yes or no. If you put no, that's your answer. If you put yes, factor it. Eli, first question. Is the first term a perfect square? Yes. Margot, second question. Is the last term a perfect square? Absolutely. Do you put A? Okay, why? Vivian, is the middle term a product of the two square roots times positive 2? That's a lot. Okay, so what we did on that last one is t times 9 times 2 going to give me 18t. Okay.
Yeah.
If it's a perfect square trinomial, which we said yes, that's part of my answer, then what's going to be the factoring of it? T plus 9 squared. Done.
What if it was 9 plus t squared?
You could do that, yes. What property says you're allowed to do that? Commutative, because it's adding. Okay. Thank you for that.
Actually, it could be associative because it's inside of.
Well, it could if those groupings change, but it's still going to be t plus 9 or 9 plus t, t plus 9 or 9 plus t. So the grouping didn't change, but good thought with the associative. Okay, good. At least you're thinking creatively, which is good. Okay, go to page 590. I went on a rant in the last class, and I'm going to not go on that rant today, or after last class. Look on page 590. Tell me what the most important part of that page is. Sorry, what piece of info that's on there is the most important? That little purple chart right there. Okay, listen to me carefully. I want all of you to do what? In fact, when I look at your quizzes I'm grading, it hurts. It hurts a little bit. I cringe when someone misses something like. And then sometimes I faint, get back up, and start grading again. But the reason I do that is because every single one of you, if you miss something, I'm just like, ugh. And I want you to do really well, but I can only do so much to help you, right? Because I could do this, do that, check this, practice that. But once you're on the quiz or test, it's all you. So if I can give you something to help you out that should help you on your quiz or test, it's going to be that chart. Okay, look at it real quickly here. In fact, I put a note. Nice joke. Refer to chart on page. What was it? 590. And I did this in my notes. A little asterisk there. Asterisk. There. Boxed it. And I said, don't forget to tell the students that. You should know that chart. Okay? I'm going to explain it right now. And I could feel it coming out here. Swivl, I won't do it again to you. Swivl was upset so badly that he turned around while I was giving it. And he just not. How long have we been a partner, a team? How long have you been my partner, buddy? Okay, but he's never seen me so mad.
Too long.
Too long. Oh my. Don't listen to them. Okay, yeah. By Swivl 3.5. Okay, let's look at that chart because I do want you guys to know what it's even saying. Okay, we've looked at polynomials when we're factoring that have 2 terms, 3 terms, or really 4 terms. They say 4 or more, but really 4 terms, okay? Whether you have 2, 3, or 4 terms, what do you always check for? GCF. And it's there, the first line says check for the GCF. I don't want to have to keep saying that because I think I've said it enough. How many of you think I've said it enough? Don't ever ask me again then. No. Always check for the GCF, and we're going to see examples of that. Okay, but if you have 2 terms, what do you check for? Look at it. Okay, GCF, and we're just going to say we always check for GCF, so what else do you check for? Difference of squares. You're like, difference of squares? Example number 4a.
Oh no.
4k squared minus 100. I'm going to ask somebody and see if they're paying attention. Lizzie, what's my first step? Hold me back, so. Hold me back here. You check for the GCF. Oh, I'm so thankful to your friends. That's okay. But, okay, GCF. Is there a GCF there?
Yes.
Yes. What's the GCF? 4. 4 can come out. You're left with k squared minus 25. That's your first step. Technically, has it been factored? Yes. It is a multiplication problem now. But is it factored completely? No. So what do I check for now? Is it a difference of squares? And you're like, wait, it is a difference. Are these two squares? Or really, are they perfect squares?
Yes.
I hope you guys remember you can factor into k minus 5 times k plus 5. Do you guys remember that from your quiz last week, a few days ago? Okay, so this is review. You square root the first one, you square root the second one, and you put k minus 5, and then you just do k plus 5. That's the difference of squares. Okay, can you factor it anymore? No. So it's completely factored, you're good. Okay, looking back at the chart. If you have 3 terms, other than GCF, because we always check for GCF, what are the 2 methods you can use to factor it? Perfect square trinomial is what we did in this lesson. And if it's not perfect square trinomials, what's the second method you can use? Yeah, and you're like, 2 binomial factors, all it means is this. Can you factor it into these 2 binomials that have 2 terms each? That's all it's asking for. And let's look at B. Oh, yes. B. 9x squared minus 3x minus 20. Is there a GCF other than 1? No. I'm going to check first perfect square trinomial, if it's a perfect square trinomial, because that's the easiest one to do. And if it is, you don't want to go through that whole other method, find out it is at the end. Is that a perfect square?
Yes.
Is that a perfect square? Is it a perfect square trinomial? Nope. Can't do that. Won't work. But do you remember the other way of factoring this trinomial? Josh?
Isn't it like multiplying -20 times 9 and then you have to find out this?
Yeah, I'm going to help you out on this one because there are bigger numbers. But aren't you trying to find out what the product of the first coefficient and the last term is? What 2 factors add up to be -3? I'll give you one of them. 15. What would be the other factor?
No. That's -10.
12.
10.
Yeah.
Okay, the 2 factors are 15 and 12. One of them has to be positive, or excuse me, one of them has to be positive, one of them has to be negative.
It's going to be -15.
Yeah, because you guys notice that it's -3 when you add them up. So you got to go -15 plus 12 is -3. Okay, then I can break it apart into 9x squared minus 15x plus 12x minus 20. Do you remember breaking into a polynomial 4 terms?
Yeah.
Okay, so I broke this middle term into these 2 terms, and you could have switched those around. That's okay. But what method are you going to be using if you have 4 terms, and it's there, and it should be up here? Factor by grouping. So I'm going to group the first 2 if I can. Yep. Second 2. Yep. Factor by grouping. This is review. So what's the GCF of the first 2 terms? What's the GCF? 3x. All right, what's left in parentheses? 3x minus 5. Okay, that's the first factoring. The second group, what's the GCF of the second 2? 4. Positive 4. What's left? 3x minus 5. Which is nice because what do you notice about those 2 now? Beth, what's your final answer?
3x plus 1 and then
That is it.
I see how this is all coming back.
It's all coming here.
I still don't understand why they're different.
What?
I mean, I get the whole.
Like the methods?
Yeah.
Okay, you know what I would say is this. That's okay. I would say you can use this method on any trinomial out there. Any of them. The perfect square,
May have your attention, teachers. During 7th period, send all 5th and 6th grade band members to the band room. Thank you.
Okay, there you go. Okay, you can use, Walker, you can use this method on any trinomial to try to factor it. Sometimes you'll get two factors that are the exact same, that's a perfect square. You'll get two that are different like this, or you'll get two without the numbers in front, and then it always works.
So, on the last.
Yeah, you can get the same thing, and that's a perfect square trinomial if you use this method.
So on the last 10-1 to 10-4.
Go ahead.
It was like, so if it was prime, we didn't like, if the number was prime that we did this method with, then we could have possibly gotten the other method.
No. If you did this method and it's prime, there's nothing else you can try.
No.
Okay. Okay, no, I'm sorry. Maybe you can ask me after. Sorry about that. Okay. Last one. Look at that chart. Look at that chart real quick. If you have four terms, what can you do? GCF, and then factor by, and that's what it says right there. Pairs of terms, that's factor by grouping. That's 4C. Last one we'll do together. 4m to the fourth n plus 6m cubed n minus 16m squared n squared minus 24m n squared. And don't forget all those exponents, variables, signs, all of it, because it all matters. Is there a GCF? What is it? 2mn. They all have a 2. They all have at least one m, and they all have at least one n. So that's the GCF, 2mn. All right, and then what's left behind is 2m to the third plus 3m squared minus 8mn minus 12n. Look at that. You got it. Yeah. Hopefully. I doubted. Yes, ma'am? Yeah. Oh. Did we factor? And the answer to that question is yes, we did factor. It wasn't a multiplication, now it is. But now look in the parentheses. Can I do something more? Factor by grouping. So you can do these two and those two. And go ahead and do it. You do it.
Can you do any grouping you want?
As long as they have common factors. So you could have switched like these guys around. You could factor those. Maybe switch those two. Factor those. Sorry. I got distracted. Question.
What about the 2 and in?
Right here?
No, like left. Up. Left.
Oh, that's still part of my answer? I'm not done yet, by the way. Yeah, I'm not done. But I factored this part to this so far.
Because then we're going to have to use brackets.
You don't have to. You could, but I wait at the end for this. Okay, I'm going to work this problem out. I get 2m plus 3 times m squared minus 4. And then at the beginning, I just put 2mn.
Well, we don't have to put the brackets because wouldn't that be like.
Oh, wow. No, listen. Could you do the brackets? Yes. You could put the bracket here and here. You don't have to because it says these three are being multiplied. Yeah. If you put a bracket, it's not wrong. All right, how many of you are doing okay on this? Semi-okay? Practice is going to help you out. Okay, your homework for tonight is numbers 21 to 45 odd, 64 to 66. And by the way, guys, on all of these, can you check them? Yes, all of them can be checked. Yeah, use Swivl. Sorry?